clearly. I'm a little shorter than the previous speakers. Hold on just a second. All right. Thanks for everybody for being here. I'm really excited to come talk to you tonight. I'm an astronomer at UT Austin, but what I'd like to discuss here is the work I did when I was at University of Colorado at Boulder for 12 years. And in particular, we built an instrument that was installed on the Hubble Space Telescope, which is why the title of this talk is When Astronauts Are Your Installers. It's pretty much a unique case to actually have people going up, and let me see if I can get the right button here. Oh, got them both. All right, where you actually can have astronauts coming in and opening up the bay doors for Hubble and sliding in something that you spent several years of your life working on. Now, there's a lot I could tell you about this, but given the time length of the talk, I had to make some decisions. I could talk to you about how you build instruments for space. I also build instruments for telescopes on the ground. Very different paradigm. There's a lot of things that have to be done differently when you're going to be installing something in a space environment. I also could talk to you about the science that my instrument is doing, and it hurts me to not spend the entire talk on that. I may give you a little hint later as to why I didn't, but the main reason is because I decided to default to the pretty pictures. And in particular, I wanted to show you, and that's why I call it what I did on my summer vacation, except it wasn't my summer vacation, it was my actual job, and that was awesome. So I'm going to have to share with you what it looked like to actually follow your instrument from the lab where you built it out to the space shuttle and then up and watch astronauts install it for you. All right, so how many of you here are familiar with the Hubble Space Telescope? Yes. Hubble's iconic. It's been going for 26 years and counting. And it's still going strong. It's not only popular with the public in terms of the outreach and the pictures, but yeah, still mastering the pointer here. And some of the great pictures, I didn't realize this one was so recent, but that I just grabbed it because it looked really nice. It's also extremely popular with professional astronomers who continue to ask for about 6 to 8 times the amount of observing time than is actually available, so it's still highly competitive. Part of the reason for that is because even though it's 26 years old, it's not the same Hubble that was launched originally. We've been up there to service it, and that means refurbing components, replacing things that are aging, but also installing new instruments. And that has allowed Hubble to maintain a real competitive edge and to continue to be timely. The last servicing mission was servicing mission 4. You might think from that this is the 4th time we went up there, but it's not. It was the 5th time we went up there. Servicing mission 3 was so big they split it in half. So servicing mission 4 took place in May of 2009, and this was the servicing mission where my instrument, which I'll talk to you about in a minute, was installed. In addition to that, they installed a second instrument. They repaired 2 instruments whose electronics had failed. They put in new gyroscopes, new batteries, new fine guidance sensors, which is what allow Hubble to point, new thermal blankets. They basically gave the whole telescope a refurb, and it's performing well ever since then. I've got a couple nice shots here. I did not take this one. This is a NASA photographer in a helicopter, but it's one of the best shots because it's something you'll almost never see. In fact, I should say this is the only time it's ever been seen. There are 2 shuttles on the launch pad at the same time. This is Space Shuttle Atlantis, which was actually going up to Hubble. This is Endeavour, and it was there as an emergency backup just in case anything went wrong on Atlantis on the way up. Hubble is not in the same orbit as the space station, so if there'd been a problem with the shuttle, they wouldn't have been able to evacuate to the space station, so they had a second shuttle prepped just in case. This is our shuttle crew here for the flight that took place. So these are the men and women who went up there and did all the great work on Hubble and achieved everything that was put in the plan for this mission. All right, so this is my instrument. This is the Cosmic Origin Spectrograph, or COS is what I'll be calling it for the rest of the talk. This is it sitting in the clean room at Ball Aerospace in Boulder, Colorado. This is the actual instrument right here. This is a handling fixture, and you can see ultraviolet instruments are very susceptible to contamination, so it's all constructed and maintained in a clean room environment. So what makes COS an interesting instrument? Why would we want to put it into Hubble? Well, it's an ultraviolet spectrograph. Let me break that down on what it means. First off, ultraviolet. That means it has to be done in space. You guys all wear sunscreen, hopefully, when you're out in the Austin summertime, so some UV comes down, but most of the UV, especially the really high energy ultraviolet light, which is what COS specialized in, is absorbed in the Earth's atmosphere, so you've really got to go into space if you want to observe. A spectrograph is not a camera. It doesn't take pictures, at least not the standard pictures. Instead, it divides the light up into energy bands. So it's like a rainbow. A rainbow is the different colors or different energies of light from the sun being scattered in our and refracted in our Earth's atmosphere. And so basically this instrument does the same thing with ultraviolet light and divides it up into energy bands. COS is not the first ultraviolet spectrograph on Hubble, it's actually the fourth, but what makes it so exciting and what made the science that we can do with it so impressive is the fact that it's significantly more sensitive, and that really opens up a whole new phase space for objects that you can look at that unfortunately I won't talk about too much, but I'll show you some couple of things at the very end of the talk. All right, so what I'm going to focus on for the rest of the talk is how do you get an instrument from Boulder, Colorado to the Hubble Space Telescope? Here's a shot from the day, the extravehicular activity EVA day 3, which is the day my instrument was put in. You have astronaut Drew Feustel on the robot arm here, and you can just barely see the head cap for John Grunsfeld. And they're about to open up Hubble to do the round. They're putting COS in, pulling out the previous instrument, putting COS in, and repairing one of the other instruments. This is the actual shot of COS going in. It's not quite as pretty. We were actually installed during orbital night. Hubble rotates or orbits around the Earth every 95 minutes, so it just so happens on the luck of the draw, by the time they got to putting ours in, it was nighttime. But you can see Drew sliding COS into the instrument enclosure and John assisting him down there. All right. So I'm going to skip several years of time. We delivered COS in 2003, and as you may remember from my second slide, the servicing mission was in 2009. We unfortunately had quite a hiatus for a while after the Columbia shuttle disaster, and for a while the servicing mission was canceled. But then there was a decision, and well, there was frankly a new NASA administrator who was a little less risk averse, and so the mission was reinstated, and at that point the instrument made its way from Goddard Space Flight Center in Maryland down to Kennedy Space Flight Center in Florida. This is the giant clean room in Kennedy where all the materials that are going to go into the shuttle payload are integrated into a canister, and here you can see COS being lifted into the shipping container it's going to go up in the shuttle. Here's another shot of it inside. All of that material is then put in this large canister here, which is a reverse match to the shuttle, cargo bay shuttle on the space shuttle, so that they can actually, as you'll see later, open that up and just exactly pull the material out and get it back in. These are members of the COS team. This is Jim Green, who was our principal investigator, and Jason McFate, who's our detector guru, who also took a lot of the great pictures we have. Now, if you spend some time in the NASA world, you find yourself learning a lot of TLAs. Is there anybody in the audience who knows what a TLA is? Yes, everybody does. Well, if you live in the NASA world, you learn a lot of TLAs, so I thought I'd put some of them up here. Three-letter acronyms, yes. So here's the question. This building here, so we have all the material ready to go out to the space shuttle, and then it goes to the first building, which is the CRF, this. Can anybody guess, based on the pictures that I showed you, what the CRF stands for in that thing? Canister, I'll give you the first one. All right, so the canister started like this, and when it came out, it's like that. This is very imaginatively named. This is the canister rotation facility. Yes, we went in, and over a period of several hours, with the help of a very large crane, that canister was moved from horizontal to vertical. You can barely see the crane in the background. Now, I'm going to take a brief pause to explain why we have all these really cool pictures, because normally an instrument team doesn't trot around following their instrument out to the launch pad on the shuttle. However, our instrument had to remain under power until launch minus 9 days. We had to run some vacuum pumps for our detector. And Kennedy Space Center said anything under power has to have 24/7 fire watch protection. This ended up being the best professional boondoggle of my entire career. I don't think I'll ever top it, because we all got passes to go everywhere on base. We got to see Space Shuttle Discovery being refurbed after its previous mission. You got to see the Space Shuttle itself being mated with its fuel tanks. It was awesome. And then, as part of our actual work, we would go every now and then and check, on fire? No. Okay, we're good. All right. So this TLA you guys might know, it's a very famous one. We're on our way out to the launch pad here with the canister, and in the background we have the VAB. Does anybody know the VAB? It's one of the more famous buildings from the Apollo era. Vehicle Assembly Building. This is where all the Saturn rockets were assembled, and it's also where the space shuttle is mated with its fuel tanks before its trip out to the launch pad. So this was about 10 or 15 miles from the canister rotation facility to the launch pad, and we were going a blistering 5 miles an hour with this, so it took several hours. So it was nighttime by the time we got there. But this is a great shot. This is one of those, we have so many versions of this shot. This one I took with my phone, I can't even remember. It was just one of those that was naturally great. So here you have Space Shuttle Atlantis on the launch pad. You have the canister now being lifted up into the RSS. Does anybody know what the RSS is? It's the rotational support structure. That's what it's called. And that's because it rotates. It's normally closed so that you can actually interact with the shuttle, but it rotates open so that you can lift up this canister, open it out, pull out all the materials for the cargo, and then lower the canister and close the RSS back up. So that was a pretty cool experience. It was so cool we got to do it twice. They got stuck the first time. This is actually the stuck position. They went a little too fast and it kind of bound and they couldn't get it out. So we got to come back the next night and do it again. This is a clean room right here running from floors 3 to 5 of the RSS, and that's where all the material that's going to go into the shuttle is unloaded. There's another shot. Yeah, so here we are inside the clean room. Here's me and Jim Green on our fire watch protection. Still not on fire. That's a good thing. And we're, you see we're all in our clean room gear. This is a shot of all the stuff that's going into the shuttle, all the payload material, and it's wrapped for contamination and safety control. And you can show, this is a shot looking vertically, so we're looking straight up. And so what you can see is the material, again, here, all the hardware ready to go in, and then this is actually the shuttle cargo bay. You can see the airlock up there. That tiny hole with the hot is actually the shuttle bay airlock. So they actually had this giant machine that would pull everything out of the canister, and then a couple days later when we'd rotated shut and we were ready with the shuttle, we pushed it back in. Plenty of time for selfies in between firewalks protection, so I just put a few of them up here showing us on the launch pad and standing here in front of the crawler that's used to take the shuttle out to the launch pad. And then we launched, so that was really exciting. We were about 2 miles away, 2.5 miles I think, from the launch, and that thing gets out of there like a bat out of hell. It's pretty amazing. It was out of sight within about 90 seconds. And this is where our actual work started. So before all that was, technically we were working, but it was really fun. So this is where we actually started doing the real work. And what we did is, first thing is we all got on airplanes and flew up to Goddard in Maryland. Because we needed to be available when the astronauts were actually installing COS. And so you have pictures here again of COS being ready to go in. You have a picture of John Grunsfeld's hands doing some of the connector work. And that's why we needed to be there, because they plugged everything in, and then we ran from the ground a series of aliveness and functional tests. And that's just to make sure, is everything hooked up? Did it turn on? If anything's wrong that the astronauts can fix while they're still outside, then we need to know that now. And so you can see us all sitting there looking expectant, and it's a pretty great moment when your instrument gets slid into Hubble and turned on and it actually works. Oh, that was interesting formatting there. And then science. So, okay, why did we do this? The engineering was fun, and let me tell you, sometimes it is just pretty cool to build something that's going into space. But nevertheless, there actually is science that drives all of the work that's done on the Hubble Space Telescope. We had a nice press release activity at NASA a couple months after we finished getting everything, several months after the actual installation, because we had to spend the summer basically making sure everything works and characterizing the instrument. And I didn't show you a picture of us sitting in a windowless office. You'll just have to imagine that one yourself. But then we had a really nice press conference, and you might remember some of these images that were shown. These are the kind of things that we do a lot of work working on press materials to try and get a lot of coverage for every time we do something important with Hubble. Now, these images are taken with two of the cameras on Hubble, Wide Field Camera 3, which was the other new instrument, and ACS, which was one of the repaired instruments. So you might be asking, okay, you just told me about this instrument costs, but I don't see anything. You did not make the cover of the New York Times. Well, I didn't. I spent a lot of work on press materials, by the way, a lot of work. But the reason they didn't make the New York Times, well, because they look like this. And this is not the sort of thing that's going to get you above the fold on the Times the day after your press conference. The bottom line is COS is a spectrograph. It divides light into different energy bands. It doesn't take pretty pictures. It creates line plots. Now, these line plots have a huge amount of physics buried in them, but it's very hard to show that in a quick soundbite or a quick image, and so we cheated. We did a few things like, oh, here's a supernova remnant, and that tiny box is what we looked at, and oh, look, we could see oxygen and carbon, and that allows us to date we knew when the supernova went off. It allows us to determine the mass of the star that actually blew up based on some of the chemicals. So you can say things like that. You can take a look at a point of light, a quasi-stellar object, and say, oh, we can see the signatures of all the gas in between that object and us. That's actually one of the big science themes for COS that we do, but it's not exactly going to be something that is going to make it for a good press release. Now, all was not lost. We did have our moment of glory. We made Jimmy Kimmel, yes, the Hubble got you story. This is one of the press releases. I was actually on this paper. We looked at an exoplanet. This is the exoplanet that's around its star. It's one of these hot Jupiters that was mentioned in the first talk. The energy from the from its sun is actually blowing this planet apart. Now, you can see this is not the data we took with Hubble. In fact, this also made the CBS Evening News, and after I spent a lot of time on the phone with the nice intern at the office, Diane Sawyer still said that Hubble took a picture of an exoplanet. We did not. We took a spectrum. This is an artist's rendition, but still, we do have our moments of glory in the spectroscopy world. All right, so where are we today? Well, Hubble's doing great. COS is doing great. Hopefully we'll have Hubble, NASA just approved funding for at least 5 more years. Yes, I know. It's very exciting. So if all goes well, we will have Hubble and hopefully my instrument for quite some time in the future. I checked the bibliography last Friday when I was writing this talk. There's over 350 papers in the literature using COS data, so that's something that I didn't actually realize at the time when I was building it is something that I look back and it makes you really proud to see that what you helped build is something that's out there and really helping scientists do great science. And coming soon, unfortunately, we don't have any plans at the moment for another ultraviolet instrument. Hopefully in 10 or 15 years we will, but at the moment I've just got to kind of stretch it out and instead use this great picture that I'm sure you've seen at just about every Astronomy on Tap, and that's the artist model of the James Webb Space Telescope here in Austin, Texas a couple years ago. That's going to be the next big news in the next couple of years, and so I look forward to hearing about it just like you guys will at Astronomy on Tap. Thanks.
All right, thank you, Gentlewoman Astronomer. Let's take some questions. All right here.
So the question was, can Hubble still be resurfaced even though the space shuttle is retired? And the answer is yes, there are no active plans, but in fact they do need to go up there. That we lifted the astronaut, well, the whole mission. During the servicing mission, the orbit was lifted, but the orbit continues to decay over time. And if we don't go up there at the very least and bring it down in a controlled fashion by the end of the 2020s, it could land somewhere we don't want it to, like the North Door or something on the way down. And that would be a shame.
We might welcome that here.
Yeah. So they did install a deorbit module when they were up there in 2009. So at a minimum, there probably has to be some way of going up there and deorbiting it in a controlled fashion. But there certainly have always been people pushing for another servicing mission. There's a famous head of Hubble operations at Goddard. He's in his he must be in his late 70s by now, who's been pushing for robotic servicing for a long time, or maybe going up with the Orion module, the deorbit, the Orion, losing my mind. You know, that thing that flies around spacecraft. That's right. Anyway, and the deorbit module that was installed on Hubble actually matched the design that the Orion had at the time. So we'll see. There's no active plans. It would be great to see it. It's still continuing to deliver a lot of great science.
Mm-hmm. Any other questions? Up in the back.
During the 6 years that it was after it had been delivered before installation, was there any inclination or ability to work on it, update it, do anything in relation to it, or was it just locked away?
So the question was, did we do anything to the instrument during the 6 years we were waiting for the mission? And we actually did. NASA did quite a bit of analysis on why the two instruments on Hubble failed, that's STIS and ACS. They failed for the same reason. It was a power converter that originally it had been sourced here in the US, and they went to a Chinese source, and it clearly wasn't as ruggedized, and so it failed in both those cases. Well, guess what? We had them on our instrument, as did Wide Field Camera 3, and so we went back and replaced all those power converters. That gave the astronauts an opportunity to play around with the tools they were going to use to repair the two on orbit, because the two instruments on orbit, they actually had to pull out circuit boards and shove in new ones, and that was not something that had ever been intended to be done. And so they had to design special tools, because they're wearing those big gloves where they can actually grab it. So they actually used our instrument as the test case and went into the clean room and carefully extracted the electronics. So we did do that. That actually meant we had to go through a whole nother round of pre-launch testing too, to make sure we still met our science requirements and we were still good to launch. So those were the two main activities that happened in between.
Okay, in the back.
Did you run into any issues during installation, or was it pretty seamless?
So for cost, no. So we were there for all of the installations, and there was a problem with Wide Field Camera 3. It was replacing Wide Field Camera 2, its predecessor, and that one wouldn't come out. They put on something to loosen the bolts, and they wouldn't loosen. And so that's very interesting, because it triggers a whole process. You've got the astronauts out there, and they only have a few hours where they can be out in their suits, so you really need to have everybody available. So they called up some guy from 20 years back when Wide Field Camera 2 had been put in, and said, we can't get the bolt to loose. And he's like, oh, we over torqued those. You just need to remove the torque limiter. And so sure enough, they went up and told Drew, just over torque that thing. And so that's what happened. Yeah. They also had some issues with STIS. This was another instrument that was being repaired, and again, it was never designed to be accessed, so they had to remove 250 bolts to get one of the backs off, and they designed a special tool to capture all those screws, because you don't really want loose screws floating around near your instrument. And that one, again, they had something that wouldn't come, a latch that wouldn't come unhooked, and so they call down to the ground, and everybody talks, and then they just told, that was Mike Massimino, they said, just rip it off. And he did. Oh, like that. He had broke it. It was, we're watching all this in real time, and yeah, but ours, it was like they slid out the old thing and shoved in the new one, locked it down, and it was like, yeah, we're good.
Any other questions? Right here.
So we don't have to work with the other instruments, and in fact you can actually run multiple instruments at the same time, but all the data handling, for example, the power, things like that, come from the telescope itself. And in fact, I didn't talk about it in this talk, but all those pictures I showed you, we actually did that whole procedure twice. We were supposed to launch in October of 2008, and then they discovered that the science and data handling module on Hubble had an electronics failure. Now, everything on Hubble is dual electronics, because you want to be able to reboot from another side if one side fails. So that was okay. We could still take data, but we now had a single point failure, and if that failed, that's what telemeters all the science data to the ground. That would have been the end of the mission. So they said, let's wait, let's get a new one, let's have the astronauts take it up. And so that's a good example of something where we actually were delayed on the final launch of the servicing mission, because something just happened to fail on Hubble 2 weeks before we were originally scheduled to go up.
One last question right here.
Okay, we all know that Sandra Bullock got to install her. How realistic were her procedures?
Okay, this is embarrassing. I've never seen the movie.
I actually haven't either. Anybody seen Gravity who can actually answer that question?
I don't know. I guess.
It was not on Earth. Not on Earth.
Yeah, the Hubble Space Telescope is not like Earth.
So I have one last question. So you got to see behind the scenes, which is such a rare thing for an astronomer, and how these things are actually put in. James Webb is unserviceable, correct? And so how do you feel about James Webb being in a place where if things go wrong, we're kind of stuck? How are you betting? Coin flip?
Okay, so Hubble's the only space telescope we've been able to service. We've had others go up there. We've had plenty of others go up there, and generally, knock on wood, they've worked really well. So James Webb, by going out to this Lagrangian point, is going to have much better observing conditions than Hubble, which is in low Earth orbit and has to deal with a lot of exclusion times and a lot of junk still in the upper atmosphere. I will say, however, whenever I watch a movie of the JWST, you can see these sped up movies of what's going to happen over the first 3 months as they're going out there. I just think, if I were on that project, I don't know how these people sleep at night. They're working it really well. I do have to say they're avoiding some of the problems that caused the original Hubble failure. So they're doing a really solid job. There's a lot of scary stuff there. So I'm betting it's going to go well, but I'm kind of glad it's not my baby.
You're not going to be in those Firewatch selfies.
Exactly.
Yeah, okay. All right, let's thank Gentlewoman Astronomer one more time.